Hi, I'd like to ask about the AlphaGo. I was told that it has about more than 2,000 CPU cores with two main algorithms. Do you think which one is more contribute to win the games, algorithm or computing power?
I don't think I know the answer to that, to be honest. Anybody else want to try?
Also, if AlphaGo match with like 4 or 5 human experts together, who's gonna win?
Well, maybe we should have a fly-off between machines. Now, that would be interesting. We'll have multiple machines play against each other. Actually, part of the training for the AlphaGo program involved playing millions of games with itself, with different versions of the program in order to reinforce the learning. We may get back some time. Cool. You always have.
Thank you for your talk. So just very quickly, what are your thoughts on the overfit problem and noisy data points? Where do you see the best practice of the optimal time for stopping training prior to overfit? Is there a generalization that we can arrive at, or is that impossible? Noisy data points and overfit and training. Is there a generalization that can become a best practice in regards to that?
So noisy data is a real problem, and it shows up in a lot of different, let me give you an example, program trading. We have program trading algorithms that are running. Most of them are based on the same general model, and they get into a lot of trouble if they have bad data. And if you've ever actually looked at the data coming across the transactions for the net, or for the stock market, there's a lot of bad data in there. Cleaning it is hard. I will offer a clue, however, and sort of a caution about trying to clean data. Imagine that you're an experimentalist and you carry out an experiment, you get some data, and everything looks pretty much according to your expectation and your theory, except for this one data point over there. And so for some scientists, they'll say, well, probably measurement error, some other glitch, I'll ignore that. The guy that wins the Nobel Prize, however, is the one that says, that's funny, and tries to find out where that came from. So I would be a little careful about trying to clean data, especially if that data might tell you something that you didn't expect.
Hi. You make the point about AI being very good at narrowly defined tasks. Sort of if you contrast that with the DeepMind folk, they're very interested in artificial general intelligence, so sort of that much broader perspective. How do you think that's a plausible goal, and how do you think how we can get from where we are now, narrowly defined, to much broader AI?
So in fact, the goal of the early AI researchers was exactly this general thing, this general purpose problem-solving GPS from Carnegie Mellon. And I think that the DeepMind guys have ambitions to try to generalize the ability of the machine algorithms to perform more complex tasks. They have shown the DeepMind systems games to play that are board game kinds of things without giving it any instruction at all, except telling it, yes, you can do that move, or no, you can't. And it managed to learn, I don't remember, a couple dozen, maybe 3 dozen games that way. But I would argue that board games are a very narrow kind of thing. This is not to diminish in any way the remarkable ability of the DeepMind team to apply their systems to different topics. But I have yet to see evidence of general purpose problem solving, either in that system or in any others, short of the attempts that were made early on in the 60s. Almost all of the problems that were tackled were very artificial in their structure and had limited dimensionality. So again, be warned, I'm not an expert on this topic, so you should ask again before the course of the day is out of people who know more than I do. That's the last one. There you go.
Thank you. Luke Huang from National Science Foundation. Thank you very much for the talk. General question is that we notice machine learning systems have become more and more complex. You mentioned there are 150 layers all these things. So how about the transparency and the interpretability of the model? What's your comments there? Thank you.
So let me elaborate on that question. There are people who are concerned that machine learning and algorithms to make decisions are not transparent and not obvious, and that they should be more so because people are concerned that given an autonomous piece of software that's making a decision that might have an effect on their livelihood or their well-being, they want to know, well, what are its inputs? Does it have any ethical concept at all? And the problem that we face with the neural networks, as I understand them, again, in my rather thin way, is that we don't really know exactly how to assess what they would do with an input that had never seen before, hadn't been trained on. And so it's very hard to respond to a transparency question. The closest I can get to it is, I'll open up the box and you can see all the weights on the dials. Does that help you? And of course the answer is no. It does raise a very interesting ethical question from my point of view, and that's trying to understand whether or not these systems, especially if they have autonomous decision-making capability, are safe, for example. So I'll give you one closing observation of my own personal skepticism about this. My wife bought one of those massage machines. There are lots of them at Google. So I guess it was a Japanese model. And it's programmed. So you can tell it, do the back or the arms or the legs or the feet or what have you. I never use it because I know that it's software that's driving it. And I'm sure it's just going to close up on me while I'm in it because of some bug. And I used to make a living writing software, and I know about bugs. So I'm very skeptical of this stuff. Nonetheless, with the Internet of Things avalanche coming, with literally billions of devices with software in them, it is important for us to have this discussion and to think very seriously about how to limit the potential hazards that poorly written software might introduce. And I think that's all the time we got.
Yeah. We've already run over time a